Hello, and welcome to the presentation for the Collaborative Web Archiving Project 3D Printing and Art and Design. Our team includes Mary Durham, Allison Ficucci, and Alyssa Jerome. This presentation was created for the SJSU iSchool graduate course Info 284, Tools, Services, and Methods for Digital Curation. This presentation consists of a brief introduction to our Archive It collection and topic, an overview of the methodology used to preserve the websites, as well as the file types and data captured. We also discuss some of the issues and challenges associated with archiving websites, especially those with multimedia components. And we conclude with a tour of our Archive It collection as it will appear to future researchers. The 8 seed sites selected for preservation within our Archive It collection include Continuum Fashion, Daniel DeBruin, Daniel Widrig, Emerging Objects, Josh Harker, Jonathan Keep, Nervous System, and Olivier Van Hert. The collection 3D Printing and Art and Design includes websites that highlight the use of 3D printing in the manufacturing and fabrication of artistic and functional objects such as pottery, sculpture, home decor, clothing, shoes, and jewelry. These works are produced using a variety of unique materials such as nylon, wood, clay, sand, plastics, metal, cement, and paper. Many of the websites feature images and videos depicting the creative process as well as additional content such as blogs, social media, and shops.
Through the use of the web archiving tool Archive It, we perform multiple test crawls to determine how to scope and modify the collection before running a production crawl. The production crawl was scheduled to run once for a length of 3 days. It included 13 ignorerobots.txt rules, 3 rules to block the capture of shop content from Nervous.com, and the addition of a 2,000 document limit for social media and YouTube sites. The crawl was expanded to include URLs containing .jpeg and .gif in hopes of capturing any absent images. Archive It recommended that we also include one-page crawls to capture the dynamic content they do not yet support, which comprise content from Vimeo, TED Talks, Kickstarter, Sketchfab, and Flickr, to name a few. Once the production crawl was complete, we examined the results using the Wayback Links and the QA report. After looking at the list of missing URLs, we chose to ignore items that contained invalid URLs, Google Analytics, and Facebook contents blocked by robots.txt before performing multiple patch crawls to capture the missing data.
Through our final production crawl, we were able to capture a total of 6.6 gigabytes of data in a wide variety of file types. By working through the issues that Mary mentioned for our patch crawls, such as ignoring invalid URLs and running patch crawls on content that was not originally crawled, we were able to capture quite a lot of new content. In fact, we managed to capture 5 gigabytes or 50,453 files of new content. This graph shows a breakdown of each file type by the number of files captured for the top 10 types. There are clearly far more files of certain types, which we can see more clearly in the next slide. In our top 10, the most common file type was HTML text, which is really not surprising considering HTML is what gives a web page its structure. The second most common file type was JPEG images. The majority of our sites displayed artwork and design elements through images and slideshows, which are represented by the second and third most common file types, JPEG and PNG. Other file types shown on this slide basically represent the structure and style of web pages, proving that preserving these elements is a crucial aspect of web archiving in order to render pages correctly. Not only did we explore the top 10 file types by number of files captured, but we also looked at the amount of data captured for each file type. Here we can see more of the dynamic content that comprises most of the websites in our collection, as represented in the metadata, such as the MP4 videos, WebM videos, and WebM audio. In order for the format types to display as separate links in our metadata, it was necessary to change the way we input each type. At first, we simply added them all separated by semicolons. However, that resulted in one long string of files in our metadata. Mary ended up re-entering all our file types separately for the entire collection in the hopes of making this field searchable to aid future researchers. Since so many of our sites had video content, one of the biggest challenges for us was capturing the videos and ensuring they would render properly in the archive site. Another issue was learning how to set the document limits for social media, and a final obstacle was making decisions on video content that was captured, but did not display on the archive pages. Josh Harker's website was full of multimedia content with multiple videos on nearly every page. As Mary described, the first test crawl we ran did not capture any videos, which really was quite a blow to us considering the sheer number of videos throughout the collection. Finally, though, we learned how to add direct video URLs as separate seeds set to crawl one page only. This allowed us to capture all the videos. However, as you can see in this screenshot, not every video that was captured will play in the archived site. Currently, Archive.it is not able to support playback of multiple inline videos, though hopefully when that functionality is available, our videos will render and playback through the archive site properly. Another obstacle we were able to overcome was deciding how much social media content to capture. We definitely didn't want to capture everything, but for some of our sites, like this one, social media feeds were very prominent. In order to capture some of Josh Harker's Facebook feed, but not his entire page, we set a document limit of 2,000 for all social media seeds. We also chose to ignore social media in our patch crawls.
Although we were able to capture all the videos within our collection as individual seeds, the videos within 3 of our archive sites cannot be viewed on the page as was possible on the live site. For example, when a user navigates to Olivier Van Hert's archive site, users will be presented with a black box on the screen where the video was once embedded. The 2 images presented here show a comparison of the video as it appears on the archive site versus that of the live web. To access the video, users will have to navigate to the main collection page and locate each video by title because the Wayback Video link is not currently populating in the yellow bar at the top of the screen. It is our hope that this issue can be resolved with the assistance of the Archive.it support team so users can experience the videos as the creators intended.
After examining the public view of the collection, we found the list of 70 seed sites to be a bit messy and difficult to navigate. To solve this problem, we turned off the public view for all of the seed sites except the 8 main sites and the 15 video sites that did not render. To further aid in searching and navigation, we created groups for the 3 seed sites. The grouped video seeds were titled using the parent seed site title followed by the video title so that they would display together when viewing the collection sites in alphabetical order. This is shown here with images of the Olivier Van Herp group. As we approach the end of our presentation, we have a short tour of the collection before we share our concluding thoughts.
Through the use of Archive.it, our team gained valuable insight into the process of preserving a collection of websites. From start to finish, we sought to identify, acquire, and preserve the essence of each site as it appeared on the live web. In preserving this collection, it is our hope that current and future generations will have the opportunity to explore the early development of 3D printing technology in the domain of art and design. Thank you, and be sure to visit our collection by clicking the link below.